Hello learners, welcome to this course on Embedded System Design using AT89C51 microcontroller. In this tutorial, I will be discussing about how to interface a 4x4 keypad with the microcontroller. The complete code and the simulation of this project is available in the GitHub repository link given below. So a keypad is a very vital input device to any embedded systems. So for example, here we are going to use a 4x4 keypad, which means I am going to have 16 switches. So here I show a typical 4x4 keypad where I have 16 switches. If I want to connect the 16 switches individually with a microcontroller, then I might require 16 IO lines. So in order to reduce the number of IO lines, we can go with a matrix keypad. So where this 4x4 stands for, the first 4 stands for rows and the second 4 stands for columns. So by using this 4 rows and 4 columns, I can connect 16 switches as I show here. So this each interjunction between a row and a column, this x1, x2, x3, x4 are rows and y1, y2, y3, y4 are columns. So each intersecting point I can have a switch. So how many intersecting points I have? I have about 16 intersecting points. So thereby I can connect 16 switches. So this keypad can be operated in 2 modes. One is either in pull-up mode or I can use it in pull-down mode. In pull-up mode, this row lines will be interconnected with the help of a resistor and it is connected to a supply. So by default, this row lines will be at logic high. And the columns will be in a normal state. In case of a pull down mode, the rows are connected to a resistor through a ground. So thereby this row lines will be at logic low by default. Low by default. The columns will be in normal idle condition. Now let us try to understand the logic behind this operation. So let us take a pull-up mode as an example. So here what we do is, by default, this rows will be at logic high, since it is connected to a pull-up resistor, right? So if I want to send some information, I have to make a corresponding row to be 0. In that case, for example, if row 1, if I give a value to be 0, then whenever I close this switch, what will happen? This signal will be routed to this column 1. Same way, if I press this switch instead of the first one, if I press the third switch, then what will happen? This 0 will be propagating to this column 3 line. If the switch is not pressed, then the 0 will not appear in any of the column lines. So that is how this keypad is going to work. So what we are going to do here, first we are going to set the rows to be 0. For example, row 1 we are going to set it to 0 and we will check the corresponding columns whether any key is pressed or not. If a key is pressed, then what will happen? I will get a 0 at the particular column line. Otherwise, I will get 1. If no key is pressed, I will get 1, 1, 1, 1. If particularly this key is pressed, in that case, what will happen? I will get 1, 0, 1, 1. Which means by seeing a 0, I know that this switch has been pressed. After scanning the first row and first column, what we will do is we will change the logic to the second row. In the second row, what will happen? row 1 will be 1. So now row 2 is activated by providing 0. Row 3 and row 4 are not activated. Okay, so while giving a signal to row 2, I will again scan the columns. Again, if this switch is pressed, what will happen? I will get a signal 1110. So by looking at the 0, we know that in second row, the fourth switch has been pressed. Then the signal will go to your row 3. So in row 3, what we will do? Again, 1101. Row 3 will be activated, and then we try to read the column 4. Then we will activate the row 4, 1110. Again read the column 1 to 4. Then after this row 4, again it will go back to row 1. So like this, the sequence is going to get repeated. And this repetition is going to be so fast that the key press can be identified in an effective manner. So the basic logic behind this keypad interfacing is we have to send a logic 0 to a particular row, and then we have to read the corresponding column. If I have a 0 in a particular column, then I can identify that a particular key has been pressed in that row. If no key has been activated, in that case I will get all ones as an output in the column. So that is how this keypad is going to work. So when you look at the keypad pin details, it has 8 lines. You can see a bus connected to this keypad, where this from left will be your X1, then X2, X3, X4, then comes your Y1, Y2, Y3, Y4. So this is a typical connection diagram for your keypad. So in pull down mode, just opposite way it is going to work. So in pull down mode, what we are going to do? We are going to have by default the rows will be at logic 0, since it is pull down using a resistor. Okay, so the rows will be at logic 0. So by default it will be at 0, 0, 0, 0. If I want to activate a particular row, what we do? We have to give 1. Okay, 5 volt to that row and read the corresponding columns. Then after this, I have to go to the second row, set it to 1, read the columns. Then I have to go to the third row, set it to 1, read the columns. Then fourth row, set it to 1, read the columns. Again go back to the first row. And this will be done at a very, very faster rate. Thereby, a key press can be identified in an effective manner. So with this simple logic, we will try to go into our program point of view. We take a AT89C51 microcontroller, where I am going to interface a 4x4 keypad with it, and I am going to connect the 4x4 keypad through port 3 of your microcontroller. So A, B, C, D represents the rows, 1, 2, 3, 4 represents the columns. So A is connected to 3.0, B is connected to 3.1, C is connected to 3.2, D is connected to 3.3. And 1 is connected to 3.4, 2 is connected to 3.5, 3 is connected to 3.6, 4 is connected to 3.7. We are going to connect a LCD to the port 2 of your microcontroller. Whenever I press a key, the corresponding key value will be displayed in your LCD. Right. So here, by using this keypad, we can just identify which key is pressed. To indicate what is the key, this switch can be corresponding to 1, or it can be to 7, or any numbers, right? So when this switch is pressed, depending upon my keypad, I have to send the corresponding ASCII value. ASCII value is nothing but American Standard Code for Information Interchange, where for each character, each digit, each symbol, we have a 8-bit representation, and it is universally accepted worldwide. So we have to send the corresponding key to the LCD. So here the matrix keypad will just indicate which key is pressed, whether switch 1 is pressed or switch 2 is pressed or switch 3 is pressed. But we have to do that mapping. If switch 1 is pressed, this should be mapped with the ASCII value of 1. Or second switch, if this switch is pressed, it should be mapped with the ASCII value of 2. So like that we have to do a mapping. Once I have done the mapping, then whenever a particular key is pressed, then I can send the corresponding ASCII value to the LCD for printing. So this is a typical ASCII chart where you see that the capital A is represented by 65 in decimal. Same way B, C, D for all the capital letters. Similarly for small letters you have. Similarly for different symbols you have. Right? So all this ASCII values can be sent to the LCD depending upon what is available in our keypad. So this is a typical keypad which we are going to use in our Proteus. So where this first key is mapped with 7. Second switch is mapped with 8. Third switch is mapped with 9. So whenever this key is pressed, what we have to do? We have to send the ASCII value of 7 to the LCD to be printed. Whenever the second switch is pressed, we have to send the ASCII value of 8 so that the LCD will show the pressed value is 8. Right? So that mapping needs to be done by the programmer. Now let us try to see the circuit part. So here I show a typical circuit to interface your keypad with the microcontroller. So here we have an oscillator circuit where we are going to use a 10 MHz crystal. And this is your reset circuit, and we are going to interface your LCD 16 cross 2 LCD. 16 cross 2 in the sense I have 2 rows. In each row I have 16 characters I can display, and I am going to use it in a 4-bit mode, which means I am going to use only 4 data lines, D4 to D7. So D4 to D7 is connected to 2.4 to 2.7. D0 to D3 we are not going to use it, so we are going to ground it. And we have 3 control lines: RS, RW bar and enable. RS stands for register select. So register select in the sense I have 2 registers. One is called as command register and I have a data register. So the data to be printed on the LCD, which is nothing but the ASCII value, can also come through this D4 to D7, and also the command in the sense where I am going to display the character, whether it is in the first row or second row. If it is in first row, which position, whether I want my character to be moved or whether I want a cursor or not, all these are commands. So the commands also will come through this D4 to D7. So in order to differentiate it, whether it is a command or a data, we make use of this RS line. If this RS is set to be 0, then the D4 to D7 will go to the command register. If RS is 1, then D4 to D7 will go to your data register. It will be treated as RS is 0, the data will be treated as command. If RS is 1, data will be treated as the ASCII value to be printed. Then I have an enable line which indicates a valid data is available in this data lines. So this enable line should be a high to low pulse. Then this data will be fetched, and depending upon the RS, it will either go to command register or it will go to data register. And RW bar is a control signal where our microcontroller is going to do the right operation most times. So we are going to directly ground it. Then we have 3 more lines, power supply lines. VSS is your ground line. VDD is a supply line. VEE is for contrast adjustment. So we can connect a potentiometer to this VEE line, thereby changing the potentiometer value. We can change the contrast also. So this is a typical circuit to connect your LCD with your microcontroller. Now let us talk about the circuit interfacing between your keypad and the microcontroller. As I said, we have 4 rows here, A, B, C, D, and 4 columns. 1, 2, 3, 4 is your columns. So the rows A is connected to 3.0, B is connected to 3.1, C is connected to 3.2, D is connected to 3.3. Then column 1 is connected to 3.4, column 2 is connected to 3.5, column 3 is connected to 3.6, column 4 is connected to 3.7. So in this way we are going to connect the keypad with your microcontroller, and here it is in pull up mode, which means by default our port lines will be at logic high. By default my port lines will be at logic high. So from microcontroller what I have to do, I have to send a 0. I have to send a 0 through this ABCD, and I have to read this 1 2 3 4. Right? First I have to send 0 to this A, and I have to read this column. Then I have to send 0 to this B and read the column. C again 0, then read the column. Then D we will send 0 and read the column. So that is what we are going to do. And this simulation will take place with the help of a Proteus 8 professional software, and the C coding will be done in your Micro C Pro for AT51 IDE. Now let us look at the program. So first we will define the LCD connections. So as I said, LCD D4 to D7 is connected to port 2.4 to 2.7, and RS line is connected to 2.2, enable line is connected to 2.3. This gives the LCD connections. Then I am going to initialize a matrix character keypad 4x4, and I am going to define the ASCII values for each position. So for example, this 7 is at 0, 0 position. 1 is at 0, 1. 9 is at 0, 2. Division is at 0, 3. So then 4 is at 1, 0. So like that we are defining 16 ASCII characters for each location in a matrix. Right? So we are defining a matrix for each coordinate. For example, keypad of 0, 0 will have the ASCII value of 7. ASCII value of 7 will be there. Same way, if I have something like 3, 3, in that case I will have the ASCII value of plus. Value of plus I will be having. So we are trying to define a matrix variable. Then we are going to write a program to scan the keyboard. As I said earlier, what we are going to do, we are going to take this ABCD, which is connected to 3.0, 3.1, 3.2, 3.3, and 1, 2, 3, 4 is connected to 3.4 to 3.7. So port 3 3.0, 3.1, 3.2, 3.3. This is rows A, B, C, D. Then 3.4, 3.5, 3.6, 3.7. These are your 1, 2, 3, 4. Right. So this 4 I am going to set it as output, and this 4 we are going to set it as input, because we are going to send 0 through these rows and we are going to read the corresponding columns. So 1, 2, 3, 4 is a corresponding column. So the rows are declared as output, whereas the columns are declared as input. So that is defined by this P3 equal to 0x_F0, which means I will have 1, 1, 1, 1, 0, 0, 0, 0. So this lower 4 bits I am configuring it as output, upper 4 bits I am configuring it as input. After declaring the port, what we are trying to do? First I am going to take the row equal to 0. So row is set with 0. So in short form I am writing it as R. Row is set with 0, and it is going to vary r equal to 1, r equal to 2 and r equal to 3, right. After 3 this for loop will exit, right. First let us take row equal to 0. So in this case what we are doing, port 3 equal to not of 1 left shift row, right. So let us take this part, and we will try to understand. So port 3 is equal to not of 1, I can write it as 0 0 0 0 0 0 0 1 left shift by row value is 0. So row value is 0 in the sense no shift, right. So this is the value, and this value I am going to do a NOT operation. Okay, this is NOT operation. So what will happen to port 3? It will be 1 1 1 1 1 1 1 0. This is for row equal to 0, right. So you can see here this bit is A, right. So we are setting A to be active. When R is equal to 0, A is set with 0, right. Same way when R is 1, what will happen? We will have again port 3 equal to not of, now what will happen? 0 0 0 0 0 0 0 1. Now I am going to do a left shift by 1 time because my row value is 1. So I am going to do a left shift by 1 time. So what will be the value? Not of 0 0 0 0 0 0 1 0, right. So when I do NOT operation, it will be equal to 1 1 1 1 1 1 0 1. So now you can see that we are giving signal to B, right. When R is equal to 1, we are going to give the signal to B. When R is equal to 2, what will happen? On a similar note, we will be giving C equal to 0. R equal to 3, we will be giving D equal to 0, right. So we are going to change one by one. First A will become 0, then B will become 0, C will become 0 and D will become 0, right. So we are activating a corresponding row. After activating a corresponding row, what we do? We try to check the columns, right. So again let us take R equal to 0. In that case we have activated the row, so this step is over. So now what I am going to do? I am going to check the column. So column is set with 0. So in short form, instead of column I am putting it as C. Column is set with 0, right. Again column is set with 0, column will be set with 1, column will be set with 2 and column will be set with 3, right. So it is going to run in this way. So first let us take column is set with 0. In that case what I am going to do? I am going to execute this condition. Port 3 is what? So port 3 already I have 1 1 1 1 1 1 1 0, right. So this is what we have set earlier, A to be active, right. So this is port 3. So this I am going to do AND operation with this option. So okay, 1 left shift by column value is 0 here. So 0 plus 4, it will be shifted by 4, right. So shifted by 4 in the sense what will be the value? So 1 I can write it as 0 0 0 0 0 0 0 1. When I want to do 4 times shift, first time, second time, third time, fourth time. So my 1 will come to this position. So it will be something like 0 0 0 1 0 0 0 0, right. Then this value I am going to AND it with port 3. So port 3 I am going to do AND of 0 0 0 1 0 0 0 0, right. So this I am going to do AND operation. Remember here when the switch is not pressed, this value will be 1, right. When the switch is pressed, what will happen? This A signal will come to this position because A and 1 are connected, right. So in my circuit, A, B, C, D and 4 columns are there. 1, 2, 3, 4, right. So here I have given 0. When I press the switch, what will happen? this 0 will appear at 1. So here I will get 0. When the switch is not pressed, when this is not pressed, what will happen? I will get 1 here. Right? If the switch is not pressed, I will get 1. If the switch is pressed, this value will be changing to 0. So when the switch is pressed, what happens? When I do AND operation, my result becomes 0. Right? So this is when switch is pressed. If switch is not pressed, what will happen? This will be 1. My output result will be 0, 0, 0, 1, 0, 0, 0, 0. So this is when switch is not pressed. Right? So you can see the difference. When the switch is pressed, my output is complete zeros, 8 zeros. When the switch is not pressed, I will get 0, 0, 0, 1, 0, 0, 0, 0. And this value, I am going to do a logical NOT. Logical NOT operation, which means it is true or false. So this is false condition. So logical NOT means my output will be true. So this is some value is there. So it is a true condition. When I do logical NOT, so we are doing exclamatory mark here. Okay, logical NOT. When I do logical NOT, it becomes false. Right? So when the switch is pressed, what happens? My if condition is satisfied. When the switch is pressed, my if condition is satisfied. If the switch is not pressed, if condition is not satisfied. So if the condition is satisfied, what we are going to do? We are going to check whether the key is released. Right? So while of the same condition, right? So until I release a key, right? So here already we have seen when the switch is pressed, I will get true here. Condition to be true. So here also it is true when the switch is pressed. When the switch is released, what will happen? This true will change to false. When the switch is released, right? When the switch is pressed, this condition will be true. But when the switch is released, it will change to false. When it changes to false, then this while loop will exit and we will try to return the corresponding keypad. What is my row and column? Right now it is 0 and 0. So what is there in 0 and 0? We have 7. So this 7 will be returned to the LCD. Right? So that is how this keypad scanning is going to work. So the concept is simple. We are going to set the rows A, B, C, D one by one. Right? First I will put 0, 1, 1, 1. Then I will put B to be 0, 1, 0, 0, 1, 0, 1, 1. Then 1, 1, 0, 1. Then 1, 1, 1, 0. Right? So we are going to activate A, B, C, D and check the corresponding columns 1, 2, 3, 4. Right. So thereby we can identify which switch has been pressed. And we can map that corresponding switch to the ASCII values given in this matrix. So this is a simple function to scan your keyboard. Now let us go to the main program where we define the variable key and do the LCD initialization part. Then in the first row, first position, I am going to display keypad interface and this will be retained for 1 second and after 1 second I am going to clear the LCD. Then in a while loop, I am going to execute this keypad scan, which is our function. So it will identify a key, that key will be loaded. The ASCII value of the key will be loaded to this key variable. Once key has a valid output, I am going to print this. Key pressed, in the second row, 6th position, I am going to display the key. When I execute this, you can see it shows in the first row key pressed. When I press key 5, the output is displayed as 5. So we will see the simulation part. So let us go to the program. So this is a program which I have explained right now. You can see the LCD connection, matrix values, Then here I define the keypad scan, then our main function. So once a program is written, we need to build it so that the C program gets converted into a hexadecimal file. So once this is done, we build our circuit in Proteus. Then dump that hexadecimal file. Right? So select the hexadecimal file. So this is a hexadecimal file. We try to import it into the microcontroller. Select the clock frequency, press OK. Then we will try to run this program. When I run this, you can see the keypad interface. Right now it is waiting for the key press. When I press 7, you can see it shows key pressed is 7. When I press this multiply symbol, it shows key pressed is multiply. When I press this 0, it shows key pressed is 0. So that is how we can get the data from a keypad and it can be displayed on your LCD. So in this tutorial, I talked about how to interface a keypad with the AT89C51 microcontroller. The complete code and simulation of the project is available in this GitHub repository. Please download and make use of it. Thanks for watching. Please subscribe for more technical learning. Thank you.